So now I have one more calculation for you today. I carried out this calculation of the derivative of the derivative of the function 1 over x. I want to take care of some other powers. So let's do that. So example 2 is going to be the function f of x is x to the n equals 1, 2, 3, one of these guys. And now what we're trying to figure out is the derivative with respect to x of x to the n in our new notation, what this is equal to. So again, we're going to form this expression, delta f, delta x, and we're going to make some algebraic simplification. So what we plug in for delta f is x plus delta x to the n minus x to the n divided by delta x. Now before, well, let me just stick this in and I'm going to erase it. Before I wrote x0 here and x0 there. But now I'm going to get rid of it because in this particular calculation it's a nuisance. I don't have an x floating around which means something different from the x0, and I just don't want to have to keep on writing all those symbols. It's a waste of blackboard energy. There's a total amount of energy that I've already filled up so many blackboards that it's just a limited amount of, plus I'm trying to conserve chalk. Okay, anyway, no zeros. So think of x as fixed. Again, in this case, delta x moves and x is fixed in this calculation. All right, now, in order to simplify this, in order to understand algebraically what's going on, I need to understand what the nth power of a sum is. And that's a famous formula. We only need a little tiny bit of it called the binomial theorem. So the binomial theorem, which is in your text and explained in an exercise, says, in an appendix, sorry, says that if you take the sum of two guys and you take them to the nth power, that of course is x plus delta x multiplied by itself n times. And so the first term is x to the n. That's when all of the n factors come in. And then you could have this factor of delta x and all the rest x's. So at least one term of the form x to the n minus 1 times delta x. And how many times does that happen? Well, it happens when there's a factor from here, from the next factor, and so on and so on and so on. There's a total of n possible times that happens. And now the great thing is that with this alone, all the rest of the terms are junk that we won't have to worry about. So to be more specific, the junk, there's a very careful notation for the junk. The junk is what's called big O of delta x squared. What that means is that these are terms of order, so with delta x squared, delta x cubed, or higher. All right, that's how. Very exciting, higher order terms. Okay, so this is the only algebra that we need to do, and now we just need to combine it together to get our result. So now I'm going to just carry out the cancellations that we need. So here we go. We have delta f over delta x, which remember was 1 over delta x times this, which is this, times, now this is x to the n plus n x to the n minus 1 delta x plus this junk term minus x to the n. All right, so that's what we have so far based on our previous calculations. Now I'm going to do the main cancellation, which is this. All right, so that's 1 over delta x times n x to the n minus 1 delta x plus this term here. And now I can divide in by delta x. So I get n x to the n minus 1 plus, now it's O of delta x. There's at least one factor of delta x, not two factors of delta x, because I have to cancel one of them. And now I can just take the limit. In the limit, this term is going to be 0. That's why I called it junk originally, because it disappears. And in math, junk is something that goes away. So this tends to, as delta x goes to 0, n x to the n minus 1. And so what I've shown you is that d by dx of x to the n minus, n is equal to n x to the n minus 1. So now this is going to be super important to you, right on your problem set in every possible way. And I want to tell you one thing, one way in which it's very important, and one way that extends it immediately. So this thing extends to polynomials. We get quite a lot out of this one calculation. Namely, if I take d by dx of something like x cubed plus 5x to the 10th power, that's going to be equal to 3x squared. That's applying this rule to x cubed. And then here I'll get 5 times 10, so 50 x to the 9th. So this is the type of thing that we get out of it. And we're going to make more hay with that next time.